Welcome to the deep dive. We sift through the noise to bring you the core knowledge you need quickly and engagingly. You're looking to get smart on a topic without getting buried, right? And that's what we aim to deliver.
And today we're diving into the specifics of data handling within the SAS ecosystem. We're focusing on key areas relevant to the data curation for SAS Data Scientists exam. That's A00-223. And for those maybe less familiar, SAS is this, powerful suite of software tools,
Yeah.
widely used for data analysis, data management.
Exactly. And our intel for this deep dive, it comes straight from practice questions and their detailed explanations, all designed for that specific exam. So think of this as your, let's say, express route to grasping some fundamental concepts of how data is managed and processed using SAS. Our mission is pretty simple. Extract the vital insights so, well, you don't have to dig through it all yourself. Okay, let's unpack this. Maybe start with data that's, coming at us in real time.
Absolutely. Yeah, one of the immediate areas highlighted in these questions is SAS Event Stream Processing, or ESP. Question 1 really zeroes in on the primary goal of pattern matching within this context.
Yeah.
What's fascinating here, I think, is the emphasis on acting on data as it happens. It's a shift,
Yeah.
from reactive to proactive.
Right.
And that can create, well, significant competitive advantages in areas like finance security.
Okay, so the answer emphasizes that pattern matching is about spotting and reacting to data patterns, like as they emerge in a continuous stream. It's not about looking back at history then, it's about right now.
Precisely.
Why is that real-time response so critical?
Well, if you connect this to the bigger picture,
Hmm.
think about scenarios where every second counts. Fraud detection is a classic one. Identifying a suspicious sequence of transactions as it unfolds can prevent, significant financial loss.
Hmm.
So the ability to dynamically respond to these patterns in real time, that's the core power here. Imagine a system automatically flagging, maybe holding, a potentially fraudulent transaction before it's even completed. That's the kind of impact we're talking about.
Got it. Okay. Now, let's maybe shift gears a bit. Let's talk about ensuring the data we actually have is clean and consistent. Question 2 brings up SAS data flux. And it asks about the component responsible for standardizing data values based on predefined rules. And SAS data flux, just for context, is SAS's toolset specifically for data quality and integration right now.
That's right. And the answer points directly to the SAS data flux standardization note. This is where those predefined transformation rules get applied. So a common example might be converting all state abbreviations, maybe CA, California, into a consistent two-letter format like CA.
Okay.
What's crucial, though, is that standardization isn't just cosmetic. It's really about ensuring accuracy and facilitating seamless interaction between different systems. I mean, inconsistent data can lead to flawed machine learning models, potentially costing businesses significant resources because of bad predictions.
So it's basically about making sure all our data speaks the same language. That makes sense. But why is having that uniform language so vital for what comes next in the process?
Well, that raises a really important point about the foundation of any analysis, doesn't it? If your data has variations, maybe a customer's name entered slightly differently across different databases, it can lead to errors in reporting, a fragmented view of that customer.
Hmm.
Standardization acts as that foundational step. It ensures the data we build, everything else upon, is trustworthy.
Makes perfect sense. Now, what if we're dealing with just a massive amount of data and need to impose some kind of order? Question 3 takes us into SAS Data Integration Studio and the function of the sort node.
Yeah, the sort node in SAS Data Integration Studio does, well, exactly what its name suggests. It arranges your data records based on one or more fields you specify.
Mm.
It might seem pretty elementary, sorting things, but it's actually a cornerstone of data processing.
A cornerstone.
Yeah, I mean, without proper sorting, trying to identify something like seasonality in sales data becomes almost impossible, which hinders things like effective inventory management.
Okay, but we sort playlists, right? Why is it such a fundamental operation for data analysis specifically?
Well, think about trying to find, say, the highest sales day of the year in a massive, totally unsorted transaction log.
Oh, yeah.
It'd be like searching for a needle in a haystack, wouldn't it?
Yeah.
Sorting provides that crucial order. It makes it possible to easily spot trends, filter for specific information, perform aggregate calculations efficiently. It's often a prerequisite for more complex analytical tasks down the line.
Okay, gotcha. Let's revisit real-time data for a moment with question 4. This brings us back to SAS Event Stream Processing, ESP, and the idea of filter windows. How does using a filter window improve the processing of these real-time streams?
What's insightful here is how it brings focus to that continuous flow of information. A filter window, in this context, basically restricts the data being processed to specific time frames. So instead of analyzing just this endless torrent of data, you're concentrating only on what's relevant within a defined period.
Ah, so it's like putting up temporal boundaries to
Hmm.
sort of ignore the irrelevant bits.
Exactly.
What's the key advantage of having that time-sensitive focus?
It significantly enhances efficiency. It prevents the processing of data that just isn't pertinent to the current analysis you're doing. If you're monitoring social media sentiment around a product launch that happened yesterday, you probably don't need to be analyzing posts from last month, right?
Right, yeah.
Time-based filtering keeps your resources focused on the information that matters most right now.
Okay. Now, how do we actually gauge the quality of our data? Assess it. Question 5 introduces SAS DataFlex Data Management Studio and this feature called Data Profiling Metrics.
Right. The data profiling metrics feature is really crucial for understanding the characteristics of your data sets after you've performed a profile. A profile is basically like an initial investigation into the data.
Oh,
And this feature lets you analyze things like the completeness of your data. How many missing values are there? Its consistency across different fields. Are dates formatted the same way everywhere? And its overall distribution, what's the range of values in a particular column?
so it's sort of like a diagnostic tool for our data's health.
That's a good way to put it, yeah.
What kind of red flags might these metrics reveal?
Oh, they can highlight quite a few potential issues. For instance, a high percentage of missing values in a really critical field might indicate a problem in how you're collecting data. Inconsistent data formats can lead to errors in calculations comparisons.
Hmm.
So understanding these metrics allows you to pinpoint exactly where your data quality improvement efforts need to be directed.
And what about when we're dealing with truly enormous data sets, like huge amounts of data? Question 6 addresses data cleansing and quality management specifically in that context.
This is where a SAS procedure called POC-DQ-Verify-Y becomes really invaluable. This procedure is specifically engineered for data cleansing and quality management when you're handling very large data sets. It helps ensure that your data adheres to predefined standards, for accuracy and consistency, but at scale. Imagine it performing checks across millions, maybe billions of records to identify and flag inconsistencies. Things like records with invalid social security number formats, maybe.
So it's kind of the industrial strength solution for keeping our massive data lakes clean then.
Pretty much, yeah.
Why is that level of rigor so important when the data volume gets so high?
Well, the sheer volume just increases the likelihood of errors and inconsistencies creeping in. It's almost inevitable. Without a robust process like POC DQ Verify, your analyses, even if the statistics are sound, could be built on a foundation of, frankly, flawed data.
Right, leading to unreliable conclusions.
Exactly. It's about maintaining confidence in your data, no matter how large it grows.
Okay, let's circle back again to the real-time realm. SAS Event Stream Processing for question 7. This asks us to define the role of an event stream itself. What is an event stream in this context?
At its heart, an event stream in SAS ESP is a continuous, never-ending flow of data records arriving in real time. It's not like a static data set that you process all at once. It's this dynamic feed that's constantly being updated and processed as new information arrives.
So it's almost like a live news feed, but for data. Constantly
It's
updated.
a great analogy, yeah.
What's the fundamental difference between this and, say, how we traditionally analyze data, batch processing and all that?
The core distinction really lies in the timing of the processing. Traditional batch processing, as you said, involves collecting data over a period, maybe hours, maybe a day, and then analyzing it in one big go. Event stream processing is all about immediate analysis and, crucially, decision-making based on the very latest data points as they occur. Think about monitoring sensor readings in a manufacturing plant. You need to react to anomalies instantly to prevent equipment failure, right? Not wait until the end of the shift.
Right, right. So it allows for immediate action rather than like later reflection.
Exactly. Immediate action.
Now, what if we have these different real-time feeds or maybe different static data sets and we need to combine them somehow? Question 8 talks about combining data sets in SAS Data Integration Studio, specifically using the join node.
The join node is the key tool for this task. It basically enables you to merge two or more data sets based on a common field, or key that they share. It's conceptually kind of similar to doing a VLOO up into spreadsheet, but it's designed for much larger, more complex data structures, of course.
Okay. And why is bringing these, disparate data sets together so crucial for getting the full picture?
Well, often, the information you need for a comprehensive understanding just isn't contained within a single source. It's spread out. For example, um, customer demographic data might live in one database, while their online browsing behavior is tracked in another system entirely.
Got it.
The join node lets you integrate these related pieces of information. You create a richer, more unified view that supports much more insightful analysis.
Makes sense. Now, what about when our data has gaps, those pesky missing values we talked about briefly? Question 9 addresses how SAS Data Integration Studio using data profiling helps us handle this. What's the approach?
The recommended approach really emphasizes a critical step: understanding the nature of the missing data before you jump in and apply any fixes. Data profiling allows you to identify which fields have missing values, sure, but also to assess the extent and, importantly, the patterns of this missingness.
So it's not just about automatically filling in those blanks then.
Precisely not. You really need to understand why the data is missing first. Is it just random, or is there some systematic reason behind it? Does the fact that it's missing itself tell you something?
Mm.
Understanding that is crucial for making informed decisions about how to handle those gaps. Whether you should impute values using statistical methods, maybe exclude records, or perhaps flag them for further investigation. Just making those choices without understanding the why can easily introduce bias into your analysis.
That's a really key point. Understand before you act.
Definitely.
Okay, finally, question 10 talks about enriching customer data using SAS Dataflux. Adding more value to our customer info, where do we even begin that process?
Well, the first crucial step, according to the explanation provided, is simply to open the data enrichment node within SAS Dataflux. This node acts as the central point where you select your initial customer data as the input source, and then you configure the rules and sources for the enrichment process itself.
Okay, and what kind of extra information can we actually layer onto our existing customer data through this enrichment?
Oh, the possibilities are actually quite broad. You could add demographic details, things like estimated age range or income level, or for business customers, maybe firmographic data industry type, company size. You could even integrate external data sources like, say, geographic information or maybe even weather data if that's relevant. The
Interesting.
fundamental goal is just to enhance your existing data with additional context. It leads to a more comprehensive, more insightful understanding of your customer base.
So, maybe a final thought for you, our listener. Considering this potent combination, we've discussed the real-time insights from ESP and the rigorous data quality management offered by tools like Dataflux and DI Studio. What novel applications or benefits might these capabilities unlock for you? In your own work, perhaps, or areas of interest? It's definitely worth pondering how these foundational data curation principles could be applied across, well, a whole diverse range of practical scenarios. Thanks for taking this deep dive with us.